Okay, to solve questions like this, number one, you have to understand that you want to find the order for NO and for Br2. And the order is the power, okay, to which the reactant is raised to. So let's say if Br2 is second order, so you write it like this. So this would be the power to which Br2 is raised to, okay? So that is the order. If it's first order, then it's 1 and it's better if, it's the same thing if you don't write it. And if it's 0 order, so when you take anything to the power of 0, it obviously becomes 1. So you do not include it in the equation. Okay, now to find out the order for NO and for Br2. So whenever you're finding out the order and you're given a question like this, number one, understand that you need to find two numbers that are constant. So in this table, in experiment 1 and 2, these two numbers are constant. Alright, so what I'm going to do is I'm going to use these two numbers, and hence, because they're constant, I'm going to find out Br2's increase in concentration. So first step, find what numbers are constant, okay? And when you find these, in the next you can find out the other reactants order. Now what you want to do is you want to compare these two numbers with these two numbers, alright? So to see the effect of Br2 on the initial ray, so you want to find out the effect of this on this. And whatever the effect of this is on this, that forms this. And the reason now I think you might even get why we exclude and why we try to find out when this is constant is because when this is constant, it has no effect on the initial rate. So what you're doing is that you're only finding out the effect of Br2 on initial rate, okay? So now to find the effect of Br2 on the initial rate, we remove this just for now. And now we start by doing this. So we take 0.04 and we divide it by 0.02. So dividing 0.04 with 0.02 gives us 2. So what I normally do is I write 2 over here. So I can remember, the 2 is in there. Alright. Now I want to find out what the order is. Okay, so now I'm going to do the same thing over here. So 6.8 into 10 power minus 3 upon 3.4 into 10 power minus 3. So doing this real quick on the calculator, and you get the answer 2. And notice how both Br2 and initial rate increase by the same factor. What does this tell you? This tells you that Br2 is first order. Now how do I know that? So let's say, okay, so I found out this was 2, right? Now if initial rate had increased, if these two had increased by a factor of 4, then if you notice really carefully, 2 into 2 is 4, right? So then that would give this. Now what that would have meant is that Br2 is second order. But in this case, Br2 is first order, bromine is first order. So we can assume that because it's first order, it increases by the same factor and it increases the initial rate by the same factor as well. So bromine increased by a factor of 2. I'm going to use a different color. So bromine increased by a factor of 2. Hence, the initial rate had also increased by a factor of 2. Alright, so now we know Br2 is first order, sorry. So Br2, first order. Okay, now time for NO. So we can't obviously, for obvious reasons, use this because this will not have any effect on the initial rate. So now that we know what Br2's order is, we can start by using either experiment 2 or 3 or 3 or 4, doesn't really matter, okay, because there are no constants with NO. However, just a suggestion, using these two to find out the order of NO would be much easier, because in this case Br2 is constant, so it will have no effect on initial rate. But I'll show you with both ways. So I'll show you how to calculate NO's order with experiment 2 and 3 and with 3 and 4, okay. So let's first do 2 and 3, okay. So now I'll just erase a bit of this just to, yeah, okay. So now to find out the order of NO, let's start by first dividing this. So the same process, so 0 0.09, 0.03, this would give you 3, okay. And then after this, now look, bromine in this case is constant, okay. And so because bromine is constant, it has no effect on the initial rate. So we don't have to include that, okay. So this makes it easy. Normally questions don't have two constants per reactant, but in this case we do, so this is a very easy question, okay. Now to find out the order for this, simple. First divide the one that's already produced with the initial, okay. So if we just put this into the calculator, we get 8.97, rounding it off to 9. Now this is a perfect example of what? Of second order. Why? Because if you notice really carefully, as I said, in experiment 2 and 3, NO increased by a factor of 3, and because of that the initial rate had also increased, but by a factor of 9. And what does this tell us? This tells us that it is that in fact NO is second order, because this is the factor which NO increased by, and times 2 of this, anything times 2 of this would make it first of all a second factor, but second order, but it would also give us 9, which is the exact factor by which 6.8 in 10 power negative 3 is raised by. All right, so this gives us second order. So now we have these two. I will show how to calculate the order from the third and fourth one as well, third, fourth experiment, but because normally in exams you won't have this and this both in the same question, because it will make it too easy. So I'll explain that, but first I'll explain how to then now create its rate equation. So to create the rate equation, now that I have this data, right? So now to create the rate equation, first of all, remember rate is equals to K, and then over here we put in, whatever reactants we have. Now in this case, there are two reactants, NO and Br2. So we'll just put in NO, Br2. Okay. Now Br2 is first order. So this, we put a first. And NO is second order, so we put a second. So now we can write this as rate is equals to K, NO2 and Br2. And that is your rate equation. So, they've put up letters over here. Sorry, this color is too bright. So they've put up letters over here. You can put up, obviously, A is equals to 2 and B is equals to 1, and we just calculated that. Now let me just clear my mess up. I've made it really messy. Okay, clean it up a little bit. Okay, now obviously this will be a little bit difficult, but as you start practicing, you will get the grip of it. Okay, so now we're gonna calculate the order of NO from the experiment 3 and 4, okay, whilst we already know the order of bromine. Okay, so to do this, I won't be using these two right now to make it a bit harder, because normally questions don't have this. Alright, so now we have this data and we have this data, okay. So first of all, let's just do what I told you guys. So when we're comparing two experiments, we always take the reactant concentration of the one below, okay, as the numerator, okay, and we take this, the first number in the two reactants that I've chosen, as the denominator. Okay, so 0 0.2, 0 0.9, and that obviously gives you 3 as well. Okay, now the trick over here is that you need to understand that you cannot just take, you know, this sorry, you cannot just exclude this and then, you know, find this out through this. That is not possible, because you need to understand that now, because bromine is changing, there's a certain change in bromine. All right, this change in bromine will cause an effect on the rate. When over here, when NO was constant, it had no effect on the rate, so we excluded it and we just found out the bromine's effect on the rate. But in this case, we have no constants in the reactant concentration, so we have to include its effect. So first, before we even use this, all right, we need to first of all remember and recall that bromine's order is first. So you need to know the order. So now I know this is bromine's first order. So I'm going to quickly just do this, 0.06 upon 0.04. So when I do this, my answer is 1.5. Now you need to understand that the initial rate that is affected by bromine, all right, gets multiplied by 1.5. Okay. Now, if bromine was second order, then I would have multiplied the initial rate by 3, because obviously 1.5 is multiplied by 2, right? But in this case, bromine is first order, so I'm going to use 1.5 and I'm going to multiply it by 6.1 to the power negative 2. Okay, now one thing, in this particular question, they have not given this value because obviously you have to calculate this value, whatever. So obviously in this case, it wouldn't have been applicable to even use experiment 3 or 4, but I'm just assuming I know this, so I can prove to you that the orders are consistent with each other. Okay, so normally they would have, like, you know, maybe like 6.9 into 10 power negative 1 or something over here, you know, normally they would have. But if you use your brain and use everything that I've just taught you, you can also calculate this. Okay, so what I'm gonna do right now is I'm gonna just assume, you know, there's a certain number. So first of all, let me just multiply this by 1.5. So 6.1 into 10 power minus 2 into 1.5. So I do this. So, okay, so 1.5 and I get 0.0915. Okay. Alright. Now we already know that NO was second order because, you know, we calculated over here. Okay. But in this case, when we would be solving this question, we wouldn't have known that NO, you know, is second order. So we would have normally had a value. So I'm just assuming, okay. Let me just in fact put in the correct value only, so it's easier for you to understand. Okay. So we're assuming that, sorry, my bad. Wait. Okay. So let's just assume that this was written over here, okay? Now, when you find the initial rate that is caused due to BR2, right? Which is this. Okay, so when you find this, now you have this value and you have this value. So this, remember, this value was already written over here, whilst this value is the one that I calculated, and this value, it has a certain significance. This value is actually the rate after you include bromine's influence on the rate. So now that I've calculated this, now I can assume that bromine is no longer present because I already calculated its effect on the rate. So now I'm gonna isolate NO and the rate, and I'm gonna now find out the effect. So now 0.0915. Okay. Assume that experiment 3, experiment 4, this is 0.8235. Now, as I told you, when you have two experiments, you want to choose the one that's below and make it the numerator. Okay, and this one will then be the denominator. Okay, so because you're comparing them, right? You're comparing them, that's why. 35 upon 0.015. Let's see if my value was correct. I tried to use my previous knowledge. Let's see. Okay, perfect. So if you plug this into the calculator, you get 9. Now I'm sure you might have caught on. My theory is proven correct and my working is also. So I don't know why it raised. So this is 9. Alright. Now if you haven't caught on, it's okay. What this means is that what I previously calculated using experiment 2 and 3, if you remember, was also 9. And what this meant was that because NO was 3, right? And the rate was 9, all right? You could tell that, this into 2 is 9, so second order. So NO is second order. So over here, if you notice, using experiment 304, where there were no constants, all right, in the reactants, and I did that deliberately to teach you how to do it without any constant values like these and these. So you're supposed to know one reactants order prior to this, which will you'll find the hint. Just find out the constants. Okay, so now that I got 9, all right. Now I know that NO was increased by a factor of 3, and because of NO, the rate was increased by a factor of 9. 9 divided by 3 is, oh sorry, my bad. What I was saying was that 3 square equals 9, second order. Right? So yeah, to sum it up, if I want to just quickly, just to quickly sum it up, whenever you get a question like this, the first thing you need to do, find two concentrations that are constant. So it's this and this, all right? That means this has no effect on the rate. Now I can just find out the effect of Br2 on initial rate. So you divide this by this. That will give you, the factor that this is increased by. And then you divide this by this and you get 2. And if you got my lecture, you'd understand that as the initial rate is increased by a factor of 2, that is completely caused due to Br2. Alright? Now that you know the order of Br2, which is first order, because it's only increased by the same factor as it was previously, as it was increased itself. Right? Now that you know this, you can use experiments 3 or 4. Okay, if this value was given, alright, but in this case you'd have to use experiment 2 and 3. But now you can use this information, and if in this case you did have a value here, you would have first found out the factor by which this is increasing, okay? And then you'd find out the factor by which and then you'd multiply this by this, so you'd get a certain value, and this would have been the value after Br2 had completely reacted. And then you would find it, and then you divide this by this. This would give you 3, and this is the factor by which NO increased. Okay, and now because you already have this, right, then you're just going to compare this by this, alright? And yeah, and you divide 0.09 by the value that would have been written here, alright? So yes, so that's how you do questions like this. Thank you so much for watching, and I hope to see you guys in the next lecture.